Hey everybody, during class, y'all had asked me to do a Zoom about a few topics, and so I had jotted those down. Um, one of them was homeostasis, so I'm going to try to get through all of these. I don't have long, so my Zooms have to be 40 minutes or under, so I'm going to try to go over those as quick as I can. And then if you still have questions, then please email me or you can text me on the number that I gave you guys if you need extra help. Okay. And then if we need to do a one-on-one Zoom and you ask specific questions about stuff you don't understand, then we can do that. Okay. So what I'm going to do is just try to go over general stuff, general information about the topics that y'all listed in class. Okay. All right, so homeostasis was the first one. So what I want to do is I'm going to share my screen with you guys. We're going to go to homeostasis. And, okay, but I'm going to make this bigger. All right, so right here, this is dealing with homeostasis. If you remember, homeostasis is when it's basically trying to reach a balance of whatever, okay, whether that's the pH of the blood or something like that. Okay, we had two different feedback systems. You had negative and positive. Couple things you will want to remember about negative feedback. Negative feedback, one, it shuts off your original stimulus. Two, it is typically going to dance around a set point. So like if you look in this picture right here, balance right here, because we're looking at body temperature, balance would be you want your body temperature at 98.6 degrees Fahrenheit, right? So if it starts to get too hot, your body starts to get too hot, this is what's going to happen until it comes back to 98.6. Then if it gets too low, this is what's going to happen until it gets back to 98.6. So it's going to continue in kind of this figure 8 type way, and it's going to keep it around 98.6. Okay, so that is what's happening with negative feedback. It's dancing around that set point, and it's trying to keep it at that level. Okay, another example, and this was under your animations on chapter 1 under modules on Canvas. But another example is speed limit. If you have a speed limit of 55 miles an hour and you start to get too fast, you're going to hit the brakes to slow back down to get back to 55. If you're going too slow, say you're going 40, and you're going to hit the gas to speed back up and get back to 55. So you're going to dance around that set point of 55. That is where you're trying to maintain it. So you can think of negative feedback as something that you're trying to maintain, your body's trying to maintain, and so therefore, like I said, it's going to dance around that set point to help to maintain it at that particular level. Now, positive feedback is different. Positive feedback enhances. It amplifies stuff, okay? One example was blood clotting, which is what you see in this picture. So you had a broken blood vessel. With your broken blood vessel, platelets are called into place. Platelets are what clot blood. And so what happens is when those platelets are called, they release these chemicals that will help to contact more platelets, and those new platelets will release more chemicals. And so this right here in the center is actually your positive feedback cycle. It will continue recruiting more and more platelets until that place is sealed. So your positive feedback loop here is here in the middle, okay? This is not something, positive feedback is not something that your body can or would want to maintain for long periods of time. Labor contractions was another example. On the animations for chapter 1, I ask you guys to make sure to go watch the 2 about positive and negative feedback loops. So if you did not, go back and watch those. It does give you some more examples of those. Let's see. Let me get to something really quick. Some other examples of positive feedback are going to be fruit ripening. And if you're looking at speed limit, it's actually if you saw a speed limit sign and you said, I think I could go way faster than that. And so you look at it as a challenge, so you speed up as fast as you can. That would be positive feedback. Negative feedback, again, you're dancing around a set point. You're trying to maintain a particular level of whatever it may be, whether that's room temperature, body temperature, blood glucose levels, and then also, like I said earlier, speed limit. Okay, so those are 4 examples of negative feedback, and then I also gave you 4 examples of positive feedback, so make sure that you know those. The other thing you want to make sure that you remember with homeostasis is the is the control mechanisms. You had 3. It was the receptor, control center, and the effector. Okay. All right, next on my list was anatomical terms. This was the end of chapter 1 part. So if you're watching your screencast, it's part 3 of 3 for chapter 1. And some students were having some issues with some of those terms. So I'm going to run, let's see, share a new screen. All right, so this is, these are actually in your review questions where it says chapter 1 and 2 EC review quiz. They're not going to look like this. This is a PowerPoint, but I put it in Word format for y'all. But this is what it looks like. So this is a good way to review these terms. Like I said before in class, you need to know how to apply this information. So you need to know the definitions, but you need to know them so that you can apply them to questions like these. So the head is what to the hips. All right, so remember, with all of these, you're gonna basically assume you're in anatomical position. And if you have to stand in anatomical position in order to answer these, then do that, okay? But your head sits above your hips. So the other thing I said that you might want to do is to take words that you actually know, above it, below it, in front of it, behind it, that kind of thing. Put those words in the blank first. Once you have those words there and you know, okay, that's the word I would use. Now, what word in A and P means the same thing? And so that's what you kind of want to do with these. So we would say the head is above the hips, and so that word would be superior. All right, your elbow is what to your wrist. So remember, again, if you're in an anatomical position, and hopefully y'all can still see me, but if you're in an anatomical position, your elbow to your wrist. Now, remember what I said in the notes? I said that if you were looking at your arm or your leg, you're typically going to use the terms proximal and distal. So proximal means it's closest to its point of origin. So point of origin for your arm is your shoulder. Point of origin for your leg is your hip, okay? So your elbow is what to your wrist. Your elbow is closer to its point of origin, the shoulder, than your wrist is. So this is proximal to the wrist. All right. Your toes are blank to your heel. Now, obviously, y'all can't see my toes, but what I would do is stand in anatomical position. Your feet should be slightly apart. Your toes are pointing out in front of you. Your heel is behind your toes. So your toes are anterior to your heel. So your toes sit in front of your heel. Now, if I said the heel is blank to the toes, that would be posterior. Your scalp. so this part right here, is what to your skull. And we use the word superficial. Superficial means it's closer to the surface of the skin. If I said the skull is blank to the scalp, then that would be deep. That's the one where it's further away from the surface of the skin. Your nose to your chin. Now, a lot of times students, when they first see this one, they go medial. But if you look, both of these are medial. Nose, chin. They're both on the midline. Okay? So, nose is superior to the chin. It sits above it. Okay? If I said the chin is blank to the nose, that would be inferior. The chin sits below the nose. Okay? Another thing you want to remember in your notes in chapter 1, part 3 of chapter 3, there are alternate words for some of these. You need to know the alternate words. So let's say on your test that maybe I said the same question. The nose is blank to the chin. And you're sitting there and you say, okay, well, the nose is above the chin. And you think, okay, well, you look on your test and you don't see the word superior on your test. Remember, you have other words that meant the same thing. Cranial and cephalic. Both of those also meant superior. Okay, so you would want to look for those alternative words if you don't see the first one that comes to your mind. Your hip bone to your umbilicus, that's going to be lateral. I don't know why it's acting so weird. The heart is medial to the lungs. The brain is deep to the sternum. Okay, I'm sorry. The brain is deep to the skull. I was thinking of another question for you guys. Okay, so those are just some examples. A couple of other things. I usually get the question, well, can some of these be more than one answer? Yes, they can. In some instances, they can be more than one answer. On your test, however, you should have one answer. And if you see that there are two answers, you let me know, because it's not supposed to be like that and I need to fix it. But for instance, what if I said your sternum to your heart? Okay, your heart, about the size of your fist, sits behind your sternum. So your sternum in that case would be anterior to your heart, but it could also be superficial, which means closer to the surface of the skin. So in that instance, you would want to look for both words and see which one I had marked. Now, there might be one where I would say the sternum is anterior and superficial. So I might put both answers in there, but you would not have to question. I would not have like letter A as superficial, letter B as anterior, and make you choose between the two. Okay, so you should have one answer for each of those. Let's see, other ways you can review these. You can go to YouTube and you could Google like anatomical terminology, and then you could probably find some more examples where they explain some more of these. That may help you actually visually seeing them point out some of these. I know that helps me as well. If I happen to come across any, I will add those maybe to the bottom of the Zoom link or something like that on Canvas, where y'all can click on them and watch them. Okay. All right. So that was anatomical terms. Buffer systems. Buffer systems is chapter 2, and it's going to be kind of toward the middle to the end. If you're looking in your notes, it's right before you get to organic compounds in your notes. So I'm going to switch my screen. I gotta see which one I gotta do. All right, so this one right here. All right, this is chapter 2. So a buffer system. A buffer system is basically kind of what keeps the pH balanced. Okay. You probably know the pH stands for power of hydrogen. The more hydrogen ions something has, the more acidic it is. The less hydrogen ions that something has, the less acidic it is, the more basic it is. So a buffer system is trying to keep it neutral, because in the body, you definitely don't want things acidic, but there are even times you really don't want things very basic either, because that can cause trouble as well. So buffer systems are there to help reduce the changes in the pH of those different body fluids. Okay. One of the main buffer systems that your body uses is the carbonic acid bicarbonate buffer system. Bicarbonate is HCO3 negative, and carbonic acid is H2CO3. So you have this picture in your notes. This is not in your first screencast, what I'm fixing to say, so you might want to jot this down. You may have to rewind it a couple times. In class, I typically go through and repeat it several times, but since y'all can go back and rewind this, then I am going to actually just kind of go through it one time fairly slowly, and then if you didn't get all of it, then just rewind it and watch it again, okay? All right, so this is what you want to write down. Carbonic acid, which is this one, is a weak acid. Carbonic acid is a weak acid produced by bicarbonate ion holding on to H+. Now remember, H+ is hydrogen ions. HCO3 negative is bicarbonate ion, and H2CO3 is carbonic acid. You need to know the names of all of those. Okay, so carbonic acid is a weak acid. It's produced by bicarbonate holding on to H+, which is hydrogen ions. H+, this right here, on the loose, so it's just saying if there's a lot of H+ floating around, then that means what? I just told you a while ago, that means it's more acidic. It means it's a more acidic solution. So to make it more acidic, carbonic acid over here dissociates. Dissociates means it breaks apart, okay? So carbonic acid dissociates into H+ and HCO3 negative, okay? To become less acidic, bicarbonate holds on to H+, so this holds on to this to form this, which is carbonic acid. If it lets go of H+, it's more acidic. If it holds on to H+, so if it's holding on to it, it's more basic or less acidic if you want to stick to the word acid. So the more H+ you have, the more acidic. The less H+ you have, the less acidic. Another way you could say less acidic is to say that it's more basic, okay? So therefore, HCO3 negative is your buffer. Bicarbonate ion is actually your buffer, because this is what's holding on to this or letting go of this in order to form or break this apart, okay? So this is your buffer. We also mentioned in class, if you're looking at the pH scale, the lower the numbers, the more acidic. The higher the numbers, the more basic. Basically, if it's below 7, it's acidic. If it's above 7, it's basic. If it's 7, it's neutral. Okay. All right. So that's the buffer system, and again, that's the part that I did not put on your screencast. So make sure that you jot all that stuff down and read back through it. If you still don't understand it, then let me know, and I will we'll try to maybe do a Zoom or something like that, so that you can hopefully understand it a little better. Okay. Next question was on enzymes. All right, so it's also chapter 2, so I'm just gonna have to kind of I tell you what, I actually had another question. It was about lipids, and since lipids are right here, I'm gonna just run through these real quick. Nobody really said specifically what they wanted to know about lipids. Main thing to know is that a lipid is a fat. The main lipids you're going to talk about in this class are your phospholipids. Phospholipids are what make up your cell membranes. And so if we go, triglycerides are pretty important too, but phospholipids, again, those make up cell membranes. They look like this. It has a phosphate group, it has a glycerol, and it has 2 fatty acids. And so the head of it is, let's go back to your notes. The head is hydrophilic, that means it likes water. The tails are hydrophobic, which means they don't like water. And you'll see more in chapter 3 of how these are set up as far as a cell membrane, and how they worked in keeping water in and out, that kind of stuff. Okay. The other main lipid that we kind of mentioned is the triglyceride. You have a glycerol with 3 fatty acids, and they bond together to form your triglyceride. Tri meaning 3. 1, 2, 3 fatty acids is where it gets its name. Okay. And then of course you had your saturated, your unsaturated fats. Saturated were the unhealthy types. Unsaturated are the healthier fats. We call them heart healthy. They're going to be liquid at room temperature. Plant oils, peanut oil, olive oil, canola oil, all those are good, the good ones. Your saturated fats, that's what makes food taste good, but it's bad for you. Butter, lard, Crisco, okay. So all those all fall under lipid stuff, okay. And then enzymes, let's see. Enzymes is toward the end, I believe, of chapter 2. Let's see. All right, hold on 1 second. Trying to figure out. Oh, that's not what I want to do. I lost my page. Okay. Enzymes starts. It's hard for me to see. I'm looking at the little bitty PowerPoint sections and I can't hardly read them, so having trouble finding it. Okay. So enzymes. One main thing you need to know, they are proteins. Okay, that most of them are proteins. They are catalysts. They lower the activation energy, which in turn increases the speed of the reaction. Okay, so you need to know all of this stuff right here on this screen right here. And I actually found kind of a cute little video. I didn't get to finish watching it a while ago. It's like five or 6 minutes long. But it compares enzymes to Pac-Man, and I know most of y'all have probably heard, if not even played Pac-Man before. But it seemed like a good example of how these work. Now just know, if I post some more videos like for you guys to watch to help y'all understand some of this stuff, if they talk about stuff that's not in your notes, like I know that one little video I just saw on enzymes mentioned induced fit. I don't tell y'all that because that's not in your book. We're not going over that part. So if a video that I post mentions stuff that's not in your notes that we don't go over, then don't worry about learning what that is, okay? If you want to learn it, that's great, but it's not something I'm going to test you on as far as that. Okay. So with enzymes, make this a little bigger. So notice over here, you have 2 chemical reactions occurring, okay? This one over here tells you that this is without an enzyme, and this one tells you this is with an enzyme. If you look right here, they refer to this activation energy as the energy barrier. And so here, the activation energy is high. So just because it's high doesn't mean the reaction can't happen. What this is saying is it's going to take this one longer to happen because it's got to go all the way up here before it can actually cause the reaction. With this one, you add the enzyme and notice that activation energy drops. So when you add an enzyme, it lowers the amount of energy required, and therefore this reaction can occur much faster. So adding the enzyme is what lowers the activation energy, and that lower activation energy is what speeds up your reaction. And those are all properties of an enzyme that I said to know. So after I post the Zoom, I'm actually going to go under the Zoom, and I'll see if I can find a few extra little videos about some of these topics that y'all had from YouTube maybe, and I'll post those underneath the Zoom, just as YouTube videos most likely, that y'all can just go on and click, and y'all won't have to go to YouTube to find them, or at least I hope you don't. I'm not sure how announcements is going to work. I'm not sure if it's going to let me do that like I do within your modules. So I'll just kind of have to see. But hopefully I can post it underneath the Zoom so that all of it's in one spot. Okay. Enzymes. The only other stuff to know about enzymes, I'm not going to watch this video again. The other stuff to know about enzymes are these things right here. Enzymes, like we said before, work like a lock and a key. There's a specific enzyme for a specific substrate, and they only fit together, okay? Once they perform their reaction, they cause a chemical reaction, and that chemical reaction produces products. So your products are what you're left over with once that enzyme has carried out its reaction. When it says usually end in ACE, it's talking about the name of an enzyme. The names of enzymes typically end in ACE: polymerase, oxidase, catalase, lipase, okay, hyaluronidase. All those words end in ASE, and so what I'm trying to get you to see is that those are all enzymes because of their name ending in ASE, okay? This is just a still picture showing you what I call the lock and key fit. So you have your enzyme here, your substrates are up here. Notice they both fit in these two active sites, here and here. Carry out the reaction, so it joins these together. Once the reaction is over, it releases it. Now, here's the big thing about enzymes you want to make sure that you know. Whenever enzymes go through this process right here, they are not harmed. This does not break the enzyme down. It does not destroy the enzyme. Notice that enzyme looks just like it did right here. So this process here does not hurt the enzyme. Matter of fact, this enzyme actually can be recycled and reused over and over and over and over. We mentioned a word right before all this. We were talking about proteins. It's called denaturation. Denaturation is where those proteins basically unfold. And when they unfold, they're no longer usable, okay? In order for a protein to be functional, it has to be folded. So the unfolding of the protein is called denaturation. Denaturation can occur if you make something too hot. If you change the pH, typically if something's more acidic, it could alter the enzyme's functionality. So most times it can be restored, but there are times where it's irreversible, meaning that it doesn't matter what you do to it, you can't get it back to its original shape or form, okay? The example it gave in your notes was if you put an egg in a frying pan and you start to heat that up, that egg is going to start to turn white where it was clear. And there is nothing you can do on this earth that's going to get it to go back from being clear, back from being white back to clear. The clear part of the egg is the protein portion. So as it heats up, it's starting to denature that protein. And so there's nothing you can go back and make it clear again. So that one is an irreversible denaturation. If the products and all are still available, then it can typically be reversed. But if not, then it's like the egg. It can't be. Again, if you have specific questions about these topics that you did not understand, I have a meeting in just a few minutes, so I can't keep going for long. But if you have specific questions about any of the stuff that we went over, a specific thing about a topic you don't understand, you can send that to me in an email, and I can try to explain it to you that way. And then if that doesn't work and we need to do just an individual Zoom between the two of us, so that I can explain a little more to you, then we can do that. Okay. Monday, Wednesday class, your test opens today, Monday, August 31st, I believe. Yeah, August 31st, September 1st, September 2nd. So your test closes September 2nd. Use Honor Lock. Tuesday, Thursday class. Your test opens tomorrow, September 1st, and is open through September 2nd, September 3rd. And you need to make sure your test is turned in by September 3rd, by 11:59 p.m. You will also use Honor Lock in order to take your test. Okay? There is a help guide about Honor Lock under announcements that e-learning posted the other day, like week before last or last week sometime. So if you need to know how to use Honor Lock, please go look at that guide. It's very simple to follow. It gives you screenshots and shows you exactly what you're supposed to do at each step on Honor Lock. Okay? So again, if y'all have questions about any other information, or if whatever I went over with the topics that y'all mentioned, if I didn't answer your question by going over it, then let me know, and then maybe we can work out something else. Okay? And I hope you guys have a great week, and good luck on your test. Okay? Don't forget to do your mastering too.